Hello everyone. So I hope you all are following my video lectures. So today we will learn polation. So first of all, what is polation? Polation is the technique of finding value of any function y. What is y? Any function of x. So finding the value of y for any value x. That means if we know some values of y, to some point x we don't know what is the value of y. So the process finding the value of y at that given point x is known as polation. Okay. So now if we as while doing a finite difference table, we had some range. Some given data is already available with us always in numerical methods. Numerical method is based on given data or available data. So since we have some data, so for some x x0 to xn, corresponding values are y0 to yn. So these are entries, these are arguments. So if these are the entries corresponding to these arguments, then finding the value of y at any x between where this x is lying between x0 to xn. That means that value x or the point where we have to find y that lies within the given range. Then finding the value of y at that point is known as interpolation. So if you listen carefully, you will understand the meaning interpolation. If range is given and the point at which we have to find y is lying within the range, then that process of finding y is known as interpolation. Okay. Now if the value of y which we have to find at any x which is not lying in this range, that is lying outside the range, that may be this side or that side. So if that point x is lying outside this range, then process of finding y is known as extrapolation. Okay. So once again, let's repeat it. I want to clear it once again that what is polation? Polation is process of finding y at any given x. So that is the general meaning. Whenever we are finding y at any given point x, that process or that method is known as polation. Now if that x lies within the given range, whatever data is given, if that x lies in that range, then that method is known as interpolation. If that x lies outside the range, then that is known as extrapolation. Okay. So in general, in most of the authors, they use in general interpolation only. So that with that also you need not to get confused, because basically what we are doing, we are pollating, we are finding unknown values. Okay. So do not get confused. Now let's make it clear by taking this example. Suppose this is the given data, that these are the arguments given and corresponding to these arguments, these are the entries. Now question is, these are the known values which we have got to know by some survey or previous experiments or whatever the source available. Now we want to know what will be the value of y at 1.5. So the method of finding this value is known as interpolation. Why? Since this 1.5 lies within this range only, -1 to 1. So 1.5 will lie here. So that is why it is known as interpolation. Now if question is what is the value of y at 3? Now you see that 3 is lying outside the range. So we call it extrapolation. If question is find the value of y at x is equal to -2, that will also be known as extrapolation. So I'm sure that you understood the method of polation. Now we will learn some techniques of polation, some techniques to find out unknowns at any given point. Okay, so let's start with first techniques, Newton forward interpolation formula for equidistant intervals or equal intervals. Okay, so I believe you all are ready with pen, notebook and calculator. So first technique for interpolation is Newton's forward interpolation formula for equidistant intervals or equal intervals. Okay. So what is the meaning of equal intervals? First of all, we should understand that if given points are x0 plus h, x0 plus 2h up to x0 nh, then what is the difference in every step? It is h. If I do plus h, I'll reach here, then plus h, I'll reach here. So if I take any difference of any two consecutive values, the difference will always be same. That is the meaning of equal interval or equidistant. All are placed at equal distance. So this is formula is specifically for this only. If this difference is not same, then this formula is not applicable. Okay. So what is the formula? If these are the given points and corresponding to these points x0 plus h up to x0 plus nh, how many points are there? These are n plus 1 points. Okay. So corresponding to these points, if these are the entries, then if we have to find the value of y at any x, now where this x is lying, it is maybe in between or outside. So if this is the value point given at which we have to find y, then this y is given by this. Now this yr just represents that at this interval, at this point we are finding. So this yr, or you can write y also, this is equal to y0 plus r delta y0 plus r in bracket r minus 1 divided by factorial 2 delta square y0 up to, this is the general term, nth term. If we keep on doing this subtraction, the up to nth difference, it will go up to r minus 1, r minus 2, r minus in bracket n minus 1 multiplied with h divided by factorial n, and the nth difference. So this is the formula. Once again I am telling, y is given by y0 plus r delta y0 plus r minus 1 by factorial 2 delta square y0. Similarly, you can write r minus 1, r minus 2 divided by factorial 3 delta cube y0 up to the nth term. Now what is r here? That r is given by x minus x0 divided by h. Okay, x minus x0 divided by h. From where we have written this, from this term only, which is understood that we are going to find this value at this point. So from this only we have written, which you can remember as formula also. R is given by x minus x0 by h. What is x0? Very first value. What is h? Step length. How you can find? You can take the difference of any two arguments and you will get to know the h. So this is the formula to find forward forward values. Now one question is, what is delta y0, delta square y0? So if you try to recall, we have already done forward difference table. Very first thing. So in forward difference table, all the leading values, very first value in each column is denoted by delta y0, delta square y0. So that means first we have to make forward difference table and then we have to apply this formula. Second question is, up to when we have to keep on going in this formula. So that will depend on the given data in the question, because on that only when you are going to construct the forward difference table, at which difference it terminates, up to there you have to write the formula. So for now you just go through this definition again, and with the example you will understand. Next we will write the formula for Newton's backward interpolation. This is for forward. Next will be Newton's backward interpolation. So next is Newton's backward interpolation formula. So first of all, let's recall what is the difference in forward and backward. So if you recall forward difference table and backward difference table, you should try to think what was the difference in representation and what was the difference in computation. So when we represent backward differences, we use nabla in place of delta. Okay. Second thing, in computation there is no difference, but In forward, reference point is always the initial point, and we take the leading differences as delta y naught, delta square y naught, delta cube y naught, like that. In backward, by the word itself we should understand we are going back. So first reference point will be the last point, xn. So in backward interpolation, reference point becomes xn, and the leading backward differences will be nebula yn, nebula square yn, nebula cube yn, like that. So that is the difference, you can say, or you can say the relation also, that what is the difference or what is the relation. That's how we distinguish between forward and backward. So if you understand this, it will not be difficult for you to remember these two formulas. If you remember one, by this reference you can write the other one. So let's come to the point. What is Newton's backward interpolation formula? For equidistant intervals. Again, you remember this is for equal intervals only. So again, if these are the given data, as you should always remember that numerical methods are always based on the given data, available data. So this is the given data, that some points are given x0 plus h up to x0 plus nh, and corresponding entries are y0 to yn. Now we have to find the value of y at any point x. Now since we are going backward, our reference point has changed to xn. In forward it was x0. So x is written in terms of xn. So x is xn plus rh is given by, is approximately given by this yn. So what is the difference? Y, now all our reference points has changed to yn. Our delta operator has changed to nebula. Now in forward it was minus r minus 1, r minus 1 minus 2, but in backward it has become plus. Okay, so that is the difference. If you correlate, it will be easy for you to understand or to remember. I'll just read it again, that some points are given and corresponding to these points some entries are given. We have to find the value of y at any point x, which is equal to xn plus rh. Then approximate value of y is given by yn plus r nebula yn plus r into r plus 1 by factorial 2 nebula square yn plus, if by symmetry I want to write, r plus 1 r plus 2 divided by factorial 3 nebula cube yn up to the nth term, or based on the given data, where r is given by x minus xn by h. Since reference point has changed, here also it is changed. What is xn? Last argument. What is h? Again the step length. X, the given point at which we have to find y. Okay. And what are these yn, nebula yn? This is the last entry. These are the leading backward differences. When you make the backward difference table, the last values are backward differences. So now I hope one thing is also clear, that when we have to use forward difference table, when we have to use backward difference table, which we have already learned how to construct. So for backward interpolation, we have to make backward difference table. For forward interpolation, we have to make forward interpolation. Now next question is when to use backward and when to use forward. So if the asked point is near to the first value or the initial value, then we have to apply forward interpolation. If you just go back little, in starting I gave an example with a table, that if we have to find y at 1.5, then if you see that 1.5 is near to initial point, for that we have to apply forward interpolation formula. And the second question was, if we have to find y3, 3 was closer to the last point, then for that we have to apply backward interpolation formula. Okay. So as I told you, y3, for that we have to use backward interpolation formula. One thing I would like to just clarify once again, that 3 is lying outside the range, so they may write it extrapolate also, or do the extrapolation. No need to get confused with that. In general, formulas are named like this, interpolation formula. So whatever value, whatever point they have asked, we have to find the value. So please don't get confused with that. Okay. So I hope you have written all the notes. Just don't keep listening only. With every point, keep writing, and then it will be easy for you to solve the questions. So note it down properly. Then let's start with numerical examples. We will take one example for both the formulas. Then it will make it more clear to you. Okay. So let's start with the first example, which is as find value of y at x is equal to 1.4. When it is written in this form, that means this is the value of x at which we have to find value of y by using suitable interpolation formula for the given data. Okay. So now we have to see that which interpolation formula we have to apply here. So first, before that, let's recall few definitions. That initial argument is 1. This is x0, x1, x2, x3, x4. This is y0, y1, y2, y3, y4. Now you see that this 1.4 is closer to 1 or 5. So if you see, this is closer to 1. So when the unknown point is close or near to the initial point, we have to apply forward interpolation formula. So for this question, we have to apply forward interpolation formula. And then for that, we have to make forward difference table. So first we have to make forward difference table, and then we'll write the forward interpolation formula, and then we'll solve. So here second thing is, you can understand that we are interpolating because this point is lying within the range. Okay. So let's make the forward difference table first. So how we have to make the forward difference table? Write the arguments here first and corresponding entries 1, 10, 2, 26, 3, 58, 4, 112 and 5, 1, 9, 4. Then how we find first difference? First difference, that is delta y. So first difference is given as this minus this, 16. You can refer that previous table we have made. y1 minus y0 is 16. What is this? This is delta y0. Then 58 minus 26, it is 32. 112 minus 58. 54. 194 minus 112. This is 82. Okay. So this is first difference. Now similarly, second difference, delta square y. This minus this, 16. What is this? This is delta square y0. Why I am writing only the first values? Since for forward difference table, we have to take the leading forward differences. So just keep writing here. So while substituting, you will not get confused. So only first I am writing for the convenience. 54 minus 32 will be 22. 82 minus 54 is 28, right? Then third difference. Up to when we have to keep on going? Either we are left with only one value or all the values becomes constant. So 22 minus 16, this is 6. 28 minus 22, it is 6. So as you can see, our forward difference table has terminated. So first of all, we have to make forward difference table. Now we have to apply the formula. So what is the formula? So as we have to apply forward interpolation formula, what is that? I have written y is y0 plus r delta y0 plus r minus 1 by factorial 2 delta square y0 plus r minus 1 r minus 2 by factorial 3 delta cube y0. Why I have written till here only? Because that our table has terminated here. After that all the difference is 0. So that is why if we make the table first, it will be convenient to write the formula up to that value. So I have written that forward interpolation formula. Now what is R? R is x minus x naught by h. What is x? The point at which we have to find the value of y. So what was the question? We have to find y at 1.4. So what is x? X is 1.4. What is x naught? X naught is first value. So x naught is first leading value, that is 1, very first value. What is h? H is step length. Now as I told you that this formula is for equidistant intervals only, so that you can verify here that everywhere this value is, this difference is 1, 1, 3 minus 2, 1, 1, 1. So that is the meaning of equidistant interval. So what is h? What is the difference between any two points? That is 1. Remember that we have to take the difference in x, not in y. So difference is 1. So what is h? H is 1. Substitute these values here and you will find the value of r. So 1.4 minus 1 divided by 1. It is 0.4. Now you know what is the value of r. You know what are the values of these differences. Substitute that and you will get the required value. So what is y naught? 10. What is r? 0.4 into delta y naught. This is delta y naught, 16, plus r, that is again 0.4. 0.4 minus 1 by factorial 2, delta square y naught, that is again 16, plus 0.4 minus 1, 0.4 minus 2 by factorial 3, and last delta q y naught is 6. We have substituted these values. So if we simplify, you can simplify this and you will see the value is 14 point. So answer should be, I am writing the final answer that you should solve and verify that what is the answer. So if we simplify all these values, the answer is 14.864. So this is the value of y at x is equal to 1.4. That is how we apply the Newton's forward interpolation formula and how we find the value of r. I hope that is clear. Now we will take one example for backward interpolation formula also. Okay. So I hope first example is clear to all of you. Let's take the second example. For the given table, find y1 and y10. So for this example, the table I have already written is in this form just to save time. So this is the given data. These are the arguments and these are the corresponding entries. So we have to find value of y at x is equal to 1 and x is equal to 10. There are two questions asked in this. So first we need to understand these questions. When we are using x is, we are solving for x equal to 1. That x is equal to 1 is near to initial point at 3, that is near to initial point. So to find this value we have to apply forward interpolation formula which we have done just now in previous example. And when we have to find y at x equal to 10, that is near to the last point. So we have to apply backward interpolation formula. So I will solve for y10, you solve it for y1. Why I have taken this example? To explain you that if both the formulas have to be applied in same question, we need not to construct the table twice. Using the same table, how we can solve this? Okay, so first of all, the basic thing is to construct the table. And as we know that in computational part, there is no difference, just the symbolic difference is there. So how to understand that? That I will explain later. So first of all, let's construct the table. So first difference is always defined with difference of these two. So 8.4 minus 4.8 is 4, 6, 3, 3.6. 14.5 minus 8.4 is 6.1. 23.6 minus 14.5 is 9.1. 36.2 minus this is 6. 12.6. 52.8 minus 36.2 is 6. 1. 16.6. 73.9 minus 52.8 is 21.1. So that is the first difference. Now if I ask first forward difference, what will be that? 3.6 delta y naught. If I ask what is first backward difference, that is 21.1. So for convenience we can keep writing it. For later it will be convenient. So 20.1 is delta y n. What is 3.6? It is nabla yn. This is delta y naught. Okay. So is it clear? In the same table how to define? This first one is forward difference. So I have written delta y naught. This last one is first backward difference. So I have written nabla yn. But computation is same. Now go to the second difference. 6.1 minus 3.6. So what is the second value? It is 2.5. 9.1 minus 6.1, that is 3. 12.6 minus this 3.5. This is 16.6, 4. 21.5, this is 4.5. Now if I ask you what is this equal to? This is second forward difference. So delta square y naught. And what is this? Nabla square yn. Okay. Now let's go to the third difference. 3 minus 2.5 is 0.5. This minus this 0.5. This minus this 0.5. This minus this 0.5. So our table terminates here. This is delta cube y naught. This is nabla cube yn. Why I am writing both the values? Since in the question they have asked two values. For one we have to apply forward formula. For next one we have to apply backward formula. So just to save time, in the same table we have written both. If they have asked only one question, so the corresponding value only you can write. Okay, so I hope that is clear. Now we will solve it for y10 only. y1 I am leaving for you since we have already done forward interpolation formula. So for that first write backward interpolation formula. This is equal to, remember what was the relation? We start with last value yn plus r plus 1 divided by r only. This is the first value. yn r nabla yn plus r plus 1 by factorial 2 nabla square yn. Then r plus 1 r plus 2 by factorial 3 nabla cube yn. Up to here only we should write as our table has terminated. Now what is yn? We know what is yn. We have in table only we can take this value. What is r? X is for y10. We are solving. X is 10. Xn is, what is xn? 9. What is h? Step length is again 1. So what is the formula for r? X minus xn by h. Substitute these values. X is 10, xn is 9 by 1. So r is 1 here. So we know all the values now. So substitute these values here. Yn is 73.9 plus R, that is 1. Nebula Yn is 21.1 plus R is 1 into 1 plus 1 by factorial 2. Nebula square Yn is 4.5 plus 1 plus 1 1 plus 2 by factorial 3. Nebula cube Yn is 0.5. If you simplify this value, you should get this value as 100. So please solve and verify. So this is how we have to apply backward interpolation formula. Main thing is when to apply. So you remember that the point at which we have to find the value, if that is close to the final value, then we apply backward formula. Similarly, the point at which value is asked, if it is close to the initial value, then we have to apply forward formula. So you solve this for y1 and verify the answer. I am writing here the answer for y1. So if you apply forward formula, then you should get the answer as 3.1. y1 should be 3.1. This I am leaving for you. I hope you will practice. Please keep writing in notebook and keep practicing. Then only it will benefit you at the most. Okay. So see you in the next video. Keep practicing. Stay safe. Bye bye.